Ladies and gentlemen, welcome to our sixth and final ZEVinnovation plenary session. Today we will talk about rules and regulations in the new maritime world. My name is Lovro Frkovic, and I'm working for the Center of Technology Transfer in Croatia, in Zagreb. And today I will talk more about project and program, project partners, Center of Technology Transfer, contention and aim of the project, and I will talk about topic of today's plenary session and today's lecturers. ZEVinnovation project is funded by Iceland, Liechtenstein and Norway through the EEA and Norway Grants Fund for Regional Cooperation. Our project benefits from a 1.6 million euro grant, and the fund recognizes sectors such as innovation, research, education, and competitiveness. Also, fund recognizes regional, cross-border, and transnational cooperation as a key driver to find shared solutions. There were more than 700 applications. Only 20 projects were selected, and one of the projects is ZEVinnovation, and a lead partner on this project is Center of Technology Transfer from Croatia. Our project lasts for 43 months. It started in 1st of June 2020, and it ends in the end of January 2024. We have 5 project partners who are actively working on the project, and they are Center of Technology Transfer from Croatia, Baltic Sea and Space Cluster as a beneficiary partner from Poland, Inovacije i Razvoj from Croatia also as a beneficiary partner, and 2 expertise partners from Norway. They are OKP and Vinco Innovation. Our company is founded by University of Zagreb in 1996, Faculty of Mechanical Engineering and Naval Architecture. Our strategic purpose is to connect science and the economy and to enhance the competitiveness of Croatian industry. Also, we want to strengthen the role of the university during this process. We want to act as a center for innovation and technology transfer. Our current activities are transfer of knowledge into economy. We are working on EU projects and lifelong learning. Also, incubation and acceleration of innovative ideas through startups, spin-offs, and student incubators. Project aim and potential: zero-emission vessels. 5 keystones are written on the left on the picture. It's an innovation hub, which is going to be an efficient and sustainable online digital network, tailored expertise through our network of experts, commercializations, best practices, transnational collaboration. That are the 5 keystones of our project. Involvement of multidisciplinary partners are going to help us to cover different fields of such as naval architecture, business innovation, technology, and we are going to support market uptake of zero-emission vessels. Finally, we came to the slide which topic of today's plenary session, that is the rules and regulations in the new maritime world. The shipping industry has been required to meet the International Maritime Organization's strict regulations. For example, require the sulfur content of ships' fuel to be cut dramatically from 3.5% to 0.5%. That was in January 2020. And how do we ensure that these new rules and regulations with energy efficiency in mind are not considered as obstacles on the way to the low and zero emission future, but they are considered as opportunities? Should ship operators need to anticipate future regulatory trends even before they happen, or should they choose vessels that are easy to adapt when the regulatory environment changes? I'm honored to introduce today's lecturers. We have Anders Valand as from Sintef. He will present the rules and regulations in making shipping more energy efficient. The second presenter is Marek Narewski. He is coming from Polish Register of Shipping, Machinery and Equipment Department, and he will present a presentation about this is a mistake. He will present also about Registry of Shipping, and Tomislav Uranda from ICAT guidelines and procedures of all electric ship registration from Croatia. After these three presenters, we will have a Q&A session, and you can write all of your questions in chat. Me and my presenters on today's plenary session are going to try to answer your questions, and we'll start the discussion. This is the information which you can contact us. Our managing director, Boris Čosić, Lovro Frković, and mail of our company. Thank you for your attention. I would like now to invite Anders Valand to share his presentations. Mr. Valand, the floor is yours.
Thank you. Thank you so much. I'm guessing a message I cannot start. Let's see if I can start it now. There.
Yep.
Okay, so now you should see my presentation.
Yep, it's okay.
Yep.
It's working.
Very good. So my name is Anders Valand. I'm working in a company called ZEVinnovation, which is part of the ZEVinnovation Group, an independent research company in Norway, which is the largest actually in the Nordic countries. And we have approximately slightly over 2,000 employees in ZEVinnovation in total. My part, ZEVinnovation, is around 350 employees currently. ZEVinnovation works within the field of ocean industries and research. So we research everything that is below the seabed, on the seabed, between the seabed and the sea surface, on the sea surface, and above the sea surface. So everything that has to do with the ocean and the extraction of resources from the ocean, and also use of the ocean for transport and maritime activities. Myself, my research is in maritime energy systems, working with maritime engines, engine systems, and as you know today, engine systems become quite complex because we are combining internal combustion engines with the batteries, with fuel cells, electric motors, quite advanced power distribution systems, and so on. So we have a lot to cover, and but it makes it interesting to be a researcher. Today I'm going to talk about these two topics, rules and regulations, and it's interesting to maybe have a slight definition in the back of your mind. I guess everybody knows or has an idea of what a rule and what a regulation is, but it's this definition of a rule as a set of explicit or understood regulations or principles governing conduct or procedures within a particular area of activity. The interesting part is that the definition of a rule contains the word regulation, and the definition of regulation contains the word rule. So they are not really strictly definitions, but you get the idea. So when it comes to rules and regulations, the question is, what's the function of them? And I've listed the 5 main functions, and I've also posited that safety has the highest priority of these 5, but it's safety, environment, health, economy, and convenience as well. So there are rules and regulations made for convenience. And it's quite important to remember that. Now, if you all know Inspector Clouseau, who's my companion on this slide, he has his own interpretation of rules, if you've seen the movies. And that's also quite important to know that even though you have written rules, you always have interpretations of how the rules work and the intentions behind the rules. So it's quite important to keep in mind. I've talked to you before, talked about these 3 main routes for emission reductions. The one that is related to how you utilize vessels, both for single vessels, but also for fleets, and even across fleets of vessels. So the pure utilization factor and how you make sure that the vessels are actually doing active work most of the time is quite important. There's also the traditional area of improving energy efficiency of ships, which we are working on, and then this factor that has to do with the fuel itself. So what is the energy that we bring to the ship to make it move? And as you all know, there's a lot of discussion on fuels, what kind of fuels to be used, and so on. I've told you before in previous presentations that the current mix of fuels globally today is 75% is heavy fuel oil. That's what's being used by global shipping. 23% more or less is marine gas oil or marine diesel oil, which means that diesel, marine gas oil, marine diesel, and heavy fuel oil, which is diesel oil, comprises almost all fuel used by global shipping. And only 2 to 3% are the remaining ones, which is mainly LNG, but it's also LPG, methanol, and some other substances being used. If you look at these 5 aspects of rules and look at how they affect these 3 main routes, you would see that now this is a busy slide, and you probably are looking at all of the arrows, but the safety affects all of these 3 routes, as does economy. So both safety and economy affects all of the routes to lower emissions. Environment and health, they affect only 2. And convenience, I've said, at least in this slide, only affects 1 of the routes. So it's quite important to see that. And I think that that's also something that most people in the maritime business would know intuitively. It's that safety and economy is what governs what we're doing. There is a case I want to take you through. I've also talked about this before, but it's quite important. This has to do with how rules work. And currently, the International Maritime Organization, which is a UN organization, and it's a very effective organization in enforcing rules on shipping. Currently, it has what we call a tank-to-wake emphasis on emissions from ships. What does that mean? Tank to wake? Well, it means that you only look at the emissions coming from the ship itself. That's the only thing you look at. So, for instance, in the case of in the case of using hydrogen on board, what would be the emissions? You probably know that would be water vapor, even water in liquid form. So, liquid water and water vapor. That's not harmful. That's okay. It's good. If you only look at the hydrogen that's in the tank in the ship being used on board and then emitted, that's the only emission you get. If you start looking at how you made the hydrogen, this picture changes quite a bit. And the same goes for any fuel you have. So if you start to look at how you made the fuel and how you brought it to the ship, that's what we call the well-to-wake emphasis on emissions. So if you look at the fuel from its birth until it has been used on board and energy is leaving via the exhaust funnel and via the propeller, that gives a very different picture than if you only look from the tank on board until it leaves through the funnel and propeller. And the IMO is now being pressured to increase their emphasis from tank to wake to well to wake. What does this mean? Well, I've shown you here, we have these new fuels, ammonia, hydrogen, some of them, and an image calling for what we call the synthetic fuels. This is another way of showing them. So over on the left side, we have what we're using today. As I said, it's basically heavy fuel oils and diesel oils. But you can have natural gas. You can use it directly from hydrogen, from natural gas, or you could use it with carbon capture. You have ammonia, which is part of the hydrogen chain. You have biofuels, which are produced in very, very different ways. Some of them are produced from food crops, which gives rather heavy ethical perspectives on biofuels. Others are produced from waste, which gives other perspectives. And then you have synthetic fuels, which is also part of what we call the hydrogen value chain. A lot of different type of fuels. And then this is also pointing to what I was talking about before. So normally we would be looking on the very right end of this figure. So the energy conversion, what kind of engines are we using? Are we using turbines? Are we using fuel cells? What's the efficiency? What are the different emission factors from this? And we're not so concerned about the left side. So the primary energy source, where does it come from? How was it produced? Is there any difference in producing LNG in Europe compared to Asia, compared to South America, North America, and so on? Is Russia doing any better than us? Are they doing worse? And so on. So we're not always too concerned about it. And I also have to say, conversely, it's quite a bit of work trying to figure out what's going on the left side. It's not very easy to figure out because these numbers are not necessarily transparent. But what happens when you change from this tank to wake perspective that I was talking about? I'm giving you an example here. The traditional discussion on what's the benefit of using LNG versus marine diesel oil. In this, if you look at the upper part of the figure, I'm showing you that if you just take the fuel itself, we know that it contains approximately 25% less carbon than per energy unit than marine gas oil does, which means if you burn it, you will be emitting approximately 25% less carbon dioxide. There's no magic about it. It's the same. I mean, if you have 25% less carbon, then you will get 25% less emissions. But if you include the well-to-wake perspective and you also include more greenhouse gases than only CO2, then you get the picture below. So you get the lower picture, and in blue here we have what's happening from between the birth of the or the production of the fuel until you have it on board the vessel. That's the blue part. Then you have the yellow part, which is the use on board, and then you have the solid yellow part, which is other greenhouse gases. In this case, it's the famous or infamous maybe methane slip. And then it starts getting interesting, because then you need to know what kind of energy converter are you using, or what kind of engine technology are you using. And then you can see the figures change quite dramatically. Suddenly, if you use, call it the wrong type of engine, you basically don't get a lot of emission cuts if you go with LNG. If you use a diesel process in your engine, you don't get the 25% cut, but you might get 50% cut. So it changes quite dramatically when you are using these, changing the perspectives. And you can also see that even for the marine gas oil, it changes. So if you look at the absolute numbers, which is grams per kilowatt hour in CO2 equivalent emissions, you can see that on the upper side, the marine gas oil has around 540 grams per kilowatt hour of emissions. But if you go to the lower one, you can see it has about 650 grams per kilowatt hour, which is quite different. So knowing how to apply the rule and use the rule and the basis for the rule is quite important. And now I'm showing you the figure, and this is why well-to-wake perspective is very important. So as I said before, use hydrogen on board. The only thing coming out is either water vapor or water liquid. But if you produce your hydrogen in different ways, the total emissions will change. This figure contains a lot of different colors. I could say that green is when you're producing something with absolutely no emissions in production whatsoever. So green would give you a zero production emission. And for if you're looking at ammonia, anything that has to do with hydrogen, we could put that almost to zero. It's not exactly zero. It's maybe just a few grams per kilowatt hour, but for practical purposes, let's keep it at zero. If you use what we call blue ammonia, blue hydrogen, that's when you're producing it from natural gas with carbon capture. You will get not zero, but you will get some emissions during production. Some emissions during production, but not zero. And if you move all the way to what we call gray ammonia or hydrogen, you will actually increase your emissions of greenhouse gases quite dramatically. In the case of ammonia, at least 35% increase. In the case of hydrogen, around 50 to almost 100% increase in emissions. And the thing is, today, production of ammonia and hydrogen is gray. Nobody is producing this with carbon capture, and nobody is producing any significant amount as a green hydrogen or ammonia. All of the prospects are saying that we're going to, sometime in the future, we're going to produce it green, but nobody's doing it today. So it's quite important to have this in mind when we're talking about all of the solutions that are coming. Another figure also emphasizing the differences between several different fuels. Maybe a little bit busy slide, but on the horizontal axis, I'm showing you what would be the potential reduction or increase relative to marine gas oil. So marine gas oil is the central vertical line at 0%. And you would see that using LNG, for instance, will reduce, as I said earlier, maybe up to between 5 and 15, maybe 18% reduction in emissions. If you go all the way on the horizontal straight line, you will find liquid biogas, which can actually bring you down to about 80% more or less reductions. And you will find that ammonia is more or less the same as liquid biogas. It's not very different. And the reason ammonia doesn't have zero in this figure is that in this case, we have put in the greenhouse gas effect of N2O, laughing gas. As you can see, the figure also says something about the energy use that you have to put into production of the different fuels. So it gives you an image of how this works. I would like to move, still keep in the area of fuels. As you know, from 2020, the IMO enforced a new set of rules saying that vessels are now not allowed to operate on fuels with more than 0.5% sulfur. They also said that if you are going to operate on the older 3.5% sulfur heavy fuel oils, you would need something to reduce the emissions of SOx from your exhaust gas, so it is equivalent to using 0.5% fuel. The introduction of this rule made some of the fuel producers start looking at, okay, can we remove the sulfur from the heavy fuel oil in the first place? So we can, and they did, and they made what's called the VLSFO. So it's very low sulfur fuel oil. It's basically heavy fuel oil which has removed most of its sulfur content. That would be nice if it worked. And it does work. Of course, it does work. You are reducing sulfur's oxide emissions quite a lot, which is very good because this regulation has to do with environment and health concerns. So it's local pollution. What they didn't do was say or give any restrictions on what could replace sulfur. And why would you want to replace sulfur? You're only going to take it out, right? Well, sulfur acts as a lubricant in the engine. It doesn't only constitute a part that you burn, but it's also part of the lubrication of the engine. So it's quite important in that aspect. And if you remove part of your lubricant, you have to replace it with something else that keeps up the lubrication, or else the engine will fail. And the IMO didn't get around to saying what that substitution should be. So now nobody really knows what's in VLSFO. And as you can see from my cutouts from a lot of cases and a lot of stories online, there is concern with regard to VLSFO and what it contains and its toxicity. There's a lot of concern. That's quite important to know when you're changing rules, and if you have this single issue focus, the law of unintended consequences will hit you in the back of the head, guaranteed. We also have this case of hazardous fuels. As you know, hydrogen, everybody's talking about hydrogen. It's explosive, it burns very easily, it seems to be quite dangerous. And you need to use this alternative design approach in the IGF code in order to get an approval from some maritime authority and some classification society. There will be rules eventually, good rules to handle hydrogen. But the problem with introducing these fuels shows us the issues that we are confronted with, and that's the lack of knowledge and competence, basically. We really don't know. We have a lot of people saying this is a no-no, you shouldn't do hydrogen and stuff, it's really dangerous, so just keep away. And then you have the people saying, no, hydrogen is just fine, you can use it for anything, and it's the best fuel ever. And the truth, of course, as always, is somewhere in between. But we need to approach this with an open mind, and we need to figure out, so what are the hard facts? And then we need to act on the hard facts. The same thing goes to toxic fuels. Strangely enough, they are allowed this fuel on board passenger vessels, but not on trading vessels under the current rules and regulations. The thing is that in these cases, all of the rules that we're looking at have their primary focus on safety. While the world is saying that global greenhouse gas emissions are so important, they should almost overrule anything else. So you're starting to get these competing interests. And safety is still the driving factor for rules. And you won't be able to budge the safety people by saying that, oh, but we need to be lenient on safety because we need hydrogen on board, or we need ammonia on board to save the world from global warming or climate change. The safety people won't budge on that. You need some other arguments, some hard arguments on how to handle this. But safety is the main issue on this. I'll give you jump to another thing. I'll give you an example of a rule of convenience. If you look at car carriers and car carriers operating out of Japan, and I see that I forgot to put credits on the image. I will fix that before we send this out, but it's MOL's own image. As you can see, you have two vessels alongside the quay here for offloading vessels, cars, I'm sorry, for offloading cars. And the rule in Japan for a lot of these car ports is that you can have two vessels alongside, and they can only be up to 200 meters in length. So what does a car carrier do? For instance, Wilhelmsen, they build a ship that's 200 meters in length because they're allowed to, and that's the biggest ship they can have. They can carry the most cars and trucks, and they sail with them. But if you look at the hydrodynamic side of things, you would find that the hull of these ships are not the most efficient. If they could be around 220 meters, then they would be more efficient. If you stretch them to 240 meters, they would still be more efficient, but not as efficient as at 220 meters. But Wilhelmsen is not allowed to operate a ship that has a hull length of 220 meters in these ports. And the only reason for the rule is that they want to have two ships alongside at any time in order to be more efficient in on and offloading of cars. It turns out, as you can see from this image, there is actually room to have two ships of 220 meters length on this quay if you arrange them slightly differently. But there is room for that. You can have an underwater hull that is longer if you want to. But the current rule says 200 meters. And that means you cannot really make the most hydrodynamically efficient car carrier because of this rule of convenience. That's quite important. So the question is then, how do you break the rule of convenience? Is it easy to do, or is it hard to do? Currently, it's hard to do. Which brings me towards the close of my session today. And my main point here is that we have competing interests when it comes to rules and regulations. So today's safety is the overruling consideration when it comes to rules. So if a rule is based on safety, that's it. Then you have to comply with it. And if you want to bring environment into a higher priority game than safety, then you're in for a fight, basically. So it's really hard to do. And you also need to understand how could safety and environment be balanced. So I'm not saying that environment should trump safety all times, or safety should trump environment all times, but we need to start looking at rules and regulations from the point of environment and local pollution, and see how we can improve the priority of environment compared to safety, and see how rules on safety impair our ability to enhance the environmental performance of ships. I could mention, for instance, rules on using pilots or using tugboats. These are safety-based rules. Using pilots, you have to have a pilot. There's several reasons for having pilots. It's knowledge of the local area, of the local sailing passage, which is very important. But sometimes, in most cases, they say that when the vessel is above a certain size, you have to have a pilot on board in order to be able to sail safely through these passages. And some vessel owners and in some trades, vessels tend to be slightly less than this length restriction to avoid having the pilot on board. And the same for using tugboats, because both having a pilot on board and having a tug on board, or having a tug assist you, costs money. So if you can avoid it by operating a slightly shorter vessel, then maybe you will try to do that. But you would then not have the most efficient ship you could. So if you want to shift the emphasis towards the environment, you would like to have the most efficient ship, and these two interests start to compete. And then the question of health, economy, and convenience is also, so what's the priority of these in competing with safety and environment? We know that economy is always there. We know that at the end of the day, cost also rules the development of shipping and trade. There's no doubt about it. So, but we need to start the work on looking at all of the rules and regulations for shipping in light of the new challenges on environmental performance and on efficiency of ships. And see where these rules are hampering the development, where they are setting arbitrary cutoffs that makes it difficult or maybe even impossible to improve energy efficiency of ships, and see how they can be changed, where you keep the safety at the level it should be, but you can change the rule to make it possible to make more efficient shipping. It's really important to do, and this is something that hasn't been done in let's say a concentrated effort yet, but we really need to get started on that. So that was my talking points for today. Thank you.
Thank you, Anders. Great presentation. I have one question regarding your presentation. As we know that the safety is the first, environment is second, and then we have health, economy, and convenience. However, there are a number of global ships that are currently reshaping the maritime world, and the industry, which has already started innovating new technologies, new alternative fuels, and how will shaping look in the 2030 or 2050 is hard to say, but we see that some shapes are described within these rules, regulations, guidelines. But which are the implications for the ship owners and the ship managers right now, but also for the future? How could companies stay ahead of the regulatories and rules, and how could they know which technology should we invest, which vessels should we will build a vessel with hydrogen? Oh no hydrogen, there will be a battery. How companies should be, how to say, ahead of these rules and regulations and take a right path for the future?
Yeah, I think that's the question that is bothering everybody today, is exactly what you're asking. But I think that the only way of either you need to be a ship owner who is hard-headed enough to take on the very large task of challenging authorities on these things and saying, so from a technical point of view, technology point of view, we can do this. We can already get this going, and we can do it. But your rules are stopping us from taking these solutions into operation. So and then you can go head on and challenge them, and some are doing that. But I think it's the most important and most effective way is that maritime authorities, classification societies, and so on need to start the work themselves on challenging their own rules and challenging the priorities in the rules with respect to environmental performance of shipping. So it's very important, because I think that for most of shipping companies, they're too small to, and their business is too small to start challenging these authorities. I mean, even Maersk finds it hard to challenge all of these things. It's they have to choose their battles as well. So and they're big. I mean, it needs to be in the best case. The beautiful case would be that everybody collaborates and tries to figure this out. But as you know, it doesn't work that way in the real world. So we need to be challenging, asking the questions to the authorities, to the classification societies, and keeping the pressure up to make sure that they do the work and involve shipping. So, yeah.
Okay, thank you, Anders. We will discuss more in the Q&A session. You could now, stop sharing. I now invite Mr. Narevsky to share his presentations and talk more about alternative fuels on board small ship.
Good morning. I hope
good morning.
You see me and hear me.
Yep, everything's all right. Just start the full screen mode. Yes. Yep.
Okay.
Yeah, now it's fine. Yeah, you can start.
Thank you. Thank you for inviting me to your event. As you know from front page of the slide. I'm for Polish Register of Shipping. Right now, I'm a research and development division. So, well, it's after a couple of years with machinery department, I have a chance to use my knowledge to more for the future, as my colleague from SINTEF said. The rules are required. Rules are to be safe. Rules are to be environmental friendly. So I would like to touch an issue of small ships, which is, I think, not in the mainstream of IMO activity, because IMO is an organization which deals with international shipping. According to statistics, we have over 90,000 of big ships, SOLAS compliant. So number of smaller ships, I think, could be 3 or 4 times bigger. So, well, problem with small ships is something I would like to talk about. My presentation will be, I hope, to be on time completed, so it's a little bit short for discussing all the issues. So on my slide, I have quite a lot of information. I try to be communicative and to touch major issues. So as the topic of the presentation are alternative fuels and what to do with them on board to have a safe ship and safe operation of its. So I would like to touch issue of alternative fuels in relation to regulatory we have regarding international shipping. I would like to talk a little bit about electricity on board, about the hydrogen on board. I have an example of using of synthetic fuels, which is a subject which was touched with Polish Register of Shipping. And I would like to give some guidance. I hope this could be well received, because it's selection or fusion of data we have from our classification activity, from activity for IMO and IAX as well. So let's start with something which we have to talk about. What is small ship? There are very different definitions for regulatory issues, and for example, for using ISO standards, length of 24 meters is something which is a kind of limit to judge. And the majority of rules have this length of the ship as a major criteria to use more stricter regulations or more relaxations. But what I would like to point out is small ships are quite often very difficult items to be designed, to be constructed, to be operated, particularly when we have new technologies on board. So on this picture over right side of my slide, you see a catamaran, which is a kind of proposal for leisure, for maybe more professional duties, but this vessel is fully saturated with new technology. You have to deal with electrical propulsion, with storage of electrical energy. There is new feature which is in this picture. There are underwater windows with additional protection to be much closer in compliance with load lines. So there's a number of critical issues for designers to be settled, and particularly when we have to decide on what kind of materials we have to use, we have to be aware that some materials are posing danger for new technologies, for application of high power electrical storage units. Plastic or composites are something which have to be very carefully used in a design process. So we have to deal with a small ship, but finally, if someone will do certification of classification, he must be assured and he must be aware of any possible problems which may arise in the future. Now we are discussing also the use of alternative fuels. Pollution from coastal shipping is quite impressive. I do not remember a figure, but from one of the presentations I got, they estimated is 20 to 30% of total pollution, which is emitted from shipping. So pressure on the use of alternative fuels, environmentally friendly is very important, and it's a lot of progress, a lot of action going now. The most important is, in case of small ships, is to use technology which is mature. Such technology we can right now point out as electricity, hydrogen, which is, I mean, very optimistic fuel. It's I think in the middle of maturity age. So we have a lot of research, we have a lot of experience, especially in the automotive industry, but to deal with safe designs for the future, we must have much more experience, and I hope this experience will not be result of fighting with problems. Another fuel which is interesting are synthetic or paraffinic fuels. One of such fuels is dimethyl ether, and I would like to discuss this application a little bit later. Problem with LNG, or which is very optimistic, popular right now for big shipping. This fuel is quite difficult to be used on the board of small ship, because basically for big shipping we have IGF code, and there's a lot of requirements regarding construction of the hull, regarding piping, passive and active fire protection. This problem is quite hard to be settled on a small ship. There are attempts also to use LPG and compressed natural gas, but experience and the number of examples is very limited. In this slide, you see some example of ships which are using alternative fuels. Electricity on the top right and top left is quite effective and quite mature technology. On the upper left side, we see a commercial boat took for inland waterway with hydrogen stored on board. In the middle lower row is one of the first smaller craft with fuel cells, which is quite interesting example of technology, with also with experience with fire on board, which proved that construction of this craft was very safe. On the top, on the in the lower road, right, this twin hull catamaran is also example of very interesting designs where we have production of alternative fuels, hydrogen on board. Such ideas and available technology allows to build also such new designs. Regarding the alternative fuels, what we have to do with them on board. First of all, it's to use them for propulsion. The second is to use for auxiliary purposes, as we say. And it's very important that any source of power, energy, and so to be implemented on board must be done. The process must design, construction, and operation must be done in a very safe way. According to the rules and regulations, it was mentioned right already that we have IMO codes or IMO conventions regarding alternative fuels. Those documents are primarily aimed for regulate safety of international shipping. So it means they are applicable basically to ships over 500 tons of GRT. So of course, there are recommendations to use the requirement of the codes, IGF code for smaller ships, but it's not so easy. So a lot of the decisions for allowing smaller ships to use alternative fuels is to be decided by administration of flag states. Similar case we have with inland shippings, where particularly in Europe we have regulations which are result of arrangements with former Rhine Commission and European Commission. So there are rules which are aimed to provide technical requirements for inland waterway shipping. And up to now, those regulations are dealing only with LNG. But positive is that there is ongoing work to include requirements for hydrogen and maybe some other alternative fuels with possible implementation date end of this year or maybe next year. Regarding the alternatives, and particularly hydrogen, which is quite promising feature. Hydrogen is very well interesting, but there are some potential problems, particularly as it was mentioned with fire safety. So as we know, for ships we have passive and active fire safety. So in the case of hydrogen, very important is to detection system, because flame is not visible. So the only way to detect is by having infrared sensors or temperature sensors to detect the increase of temperature, and possibly in some circumstances maybe other methods based on data fusion could provide some information for ship fire management system, fire safety system. So gas of course is interesting, is very very promising, but what I would like to put your attention is that measures to provide safety are to be very complex, particularly when we're dealing with new designs. I think that I already mentioned that with small ship we have very limited space on board. So placement of storage of alternative fuels, conversion technology, and so could be quite difficult, particularly if the boat or craft is to be used for commercial purposes. And further on, if in case of any problems, particularly fires, which according to statistics could have place, are constituting about 30% of events which are registered by, for example, by EMSA. So using proper firefighting methods is very important, because in case of small craft, using a water sprays is also recommended, but traditional methods of using water could be very disastrous, because the small craft could very quickly sink. Yeah. So issues related to fire safety, I think it's something which is to be of very prime importance. Regarding the class rules, you know that classification society are issuing rules or guidance. The weight of such documents is quite different. Rules are more strict. Guidelines can be more flexible, but basically technical programs progress and the content of the rules depends on the experience we are having. So with the use of alternatives, we are not fully experienced yet. We have a lot of paper information. There's a lot of research, but conversion information from research into the construction, design, classification or certification standards is quite difficult, because from our side, when we are trying to implement our requirements, quite often we have to discuss the issue, because the point of view of designer, the ship owner is quite different. But we have to meet somewhere in the middle. Small ships, once again, small ships are having demand for energy. So demand of energy is very important to handle this energy on board. And one of the very important points for starting of the project is to have realistic design requirements, to have such requirements that could be implemented in practice. Of course, if project needs to be certified in the end as a kind of documentation approval process or testing of new features and final certification, problems are to disclose as much as critical knowledge to people which are taking care on the ship safety. This is quite often a problem because patents, because company commercial secrets, and it has to be remembered that the class society is partner which allows you to have independent review, independent assessment of design, of construction and operation of the craft, having in mind all issues of the safety. Electricity. You see some examples of smaller crafts which were subject of PRS acceptance. The crafts in upper row are small ferries operated in one of the cities in Poland. The project has been completed 10 years ago, and they are using electrical energy mainly in summer to provide communication within river system, which is quite complex in the city. Ships are operated very efficiently, but what I would like to point you out that you see that it's very similar to the automotive project bus, yeah, but bus is having wheels, and in this case, having ability to float needs to have buoyancy. So everything which is necessary for the function of this vessel is to be placed inside the hull. Such crafts right now could be quite difficult to be constructed because from the first in view, we see that if you would like to put a lot of new equipment on board, you may have a buoyancy problem. As a complexness of new technologies, this is example of the project which is ongoing now, but it's very important that the safety issues are first issues to be discussed with design people. Construction is a process which needs to be repeated, same as design circle is to be repeated number of times to get the final construction. In case of all new features on board, we have to make kind of optimization to meet at certain point when we have safe construction in the end. I discussed this issue of small craft. You see a picture from some analysis done on safety issues, and in this example you see on the left side some critical points related to construction of this boat. So in a small ship, if you would like to have this efficient, if you would like to have to be safe, you must have space. So space needs buoyancy. So in case, for example, of number of people on board, which ship owner would like to be as much as possible, we can have a point when requests from rules is that you must have a place on board when all the passengers could meet for evacuation. So I don't think in this craft, or like, well, in normal bus, there's also not possibility. There is no possibility to get all the people to evacuate from the craft. Another issue is in this craft is battery. Battery is placed under the floor. So in case of any fire, you have to evacuate the people, and of course the crew, which is guiding the craft, is in the front part of the hull, so they have to be in a post on a bridge, as we can say, as long as the people will be still on board. So in case of fire, in case of fumes, we must have very efficient ventilation system. This is, I mean, a nice example how to start discussion on the safety. It must take into account all possible risks, and mitigation measures must be finally elaborated. I mentioned synthetic fuels. There's no much experience with ships using this kind of fuels. I got one information about the project which was completed in Sweden. It's a green pilot boat with methanol on board as a fuel, and they also did some testing with other type of synthetic fuels. The other issue is the other project it was completed in Poland. Is a small craft. Basically, it's a yacht which is operated by the Technical University of Gdańsk as a floating club, and having a project founded by European Union. One of the researchers completed PhD on this project. The project took conversion of a commercial yacht diesel engine into DME. They elaborated all additional fire protection measures. They elaborated a very interesting control system to make to test behavior of this fuel on board. As you see on the right picture, the DME is very similar to LPG, so they are using typical tanks from trucks for storage. The yacht is operated for research purposes, so we are able to approve it, having all the documents, including risk analysis. On the Swedish boat, you see a kind of safety measures done with how to deal with bunkering of methanol on board. So dedicated fuel tanks were put inside, and of course the bunkering station is also located on the open deck, together with some nitrogen immersion possibility. In case of hydrogen, which is to be used as a prime source for fuel cells, maybe for some internal combustion engines, hydrogen is to be stored on board in a kind of tanks. You see a selection of tanks according to international standards, and this blue arrow points out on a type of tanks which potentially are interesting for storage of compressed hydrogen. For small craft, compressed hydrogen is very interesting because it's quite easy to implement it. If someone would like to use liquid hydrogen, we have much more requirements regarding safety, and all the piping and so is to be double walled, and basically open deck storage of fuel, and it's quite a complex system. So we have as a register some experience with composites, composite pressure vessels for application on board. One of the cylinders is type approved for military application, I can say. So in case of hydrogen storage, the most optimal is to put hydrogen tanks in racks on board, as you see on project of this workboat. Here, hydrogen cylinders are in racks, so exchange of cylinders is exchange of hydrogen fuel is quite easy. In this ZEM ship, this passenger ships on the top left is example of ship which was built over 10 years ago in Germany. Fuel cells 2 times 50 kilowatts, fueled with hydrogen. Hydrogen tanks were placed under the floor in the cabin, and it's interesting example because these ships experienced fire inside. So there are some available pictures of condition of the interior of the craft after the fire, but luckily fire was inside, and storage tanks for hydrogen were not touched. I think that this is a kind of situation which quite often happens with the yacht, with motorboats, which are fueled with petrol. When then, in case of fire, we can experience fire of the total structure over the water, but something which is under the water line could survive. So maybe such placement of tanks is not so bad, because in this case we can have ability to cool the cylinders as long as the firefighting action, as long as the fire or elevated temperature of electrical batteries is having place. Coming to the conclusions, complex engineering analysis of alternative fuels usage and propulsion system functionality in ships with electrical propulsion system is recommended to be done. Why? Because we have to identify the problems of safe storage and use alternative fuels on board. Identification of cases of insufficient propulsion power in early stage of the design is necessary. This is problem we identified on some boats with electrical propulsion, when budgets for the project were not big enough, and the conversion of the boats into the propulsion took place with not so big assistance from design office, and installed electrical power was insufficient for the vessel to cope with operational conditions. So if we have a boat with total electrical power, we have to have a battery management system designed in a way to allow safe return to the place of safety. Something similar as we have with IMO requirements for safe return of passenger ships on board. In case of small ships, maybe such approach is also necessary, particularly in case when we have boat with totally electrical propulsion. So amount of energy stored on board is to comply with the customer requirements, as well as with regulations, either class society or administration. Propulsion components, well, the best is to have components which are certified. This is a problem sometimes because certification costs, but cost of certification can be marginal in case we have something which is to be operated with people on board. So I think independent certification company, independent design assessment is something which is necessary, which is able to lead to final safe design. And the most important is that people which are dealing with ship design, with craft design, are to be naval architects with experience in either ship structure design, ship hydrodynamics, and all engineering issues which could be settled in a holistic way to allow final safety of the craft. I think this is, and maybe my presentation was well topic is very wide. So in case someone is interested in having in getting some comments on or some maybe other action from outside, we are open to provide you a hand. Thank you for listening.
Thank you, Mr. Narevsky, for this interesting presentation. The topic is really wide. I have maybe one question considering your experience in Poland. As I heard from your presentation, you had a few projects already in Poland which put batteries or hydrogen on board ships or some other kind of alternative fuels. From your experience, what is the situation now and then? Is it now faster to register some kind of a ship with alternative fuels? What was the time to have it a ship a register from 10 years ago and today?
I think the most important is to deal with people who has some who possess some knowledge. As you know, with European Union, we have dual certification ways, something which is boat, pleasure boat. The process of certification is much simpler, but it doesn't mean that we have to neglect safety issues. But basically, in case of crafts used for pleasure purposes, I think that certification process could be finished quite quickly. However, there are some issues which are necessary to be coped. As I said, buoyancy, hull must be safe. Yeah. So everything which is placed inside also is to be safe. So depending on the quality of technical documentation, the process could take shorter or longer time. But well, new design is something which is sometimes problem for us as well. So I remember this electrical craft which I was dealing with. All the approval was completed with not more than 4 or 5 months, starting from the first point of contact. There was, as far as I remember, we have first contact, and after that time there was 3 or 4 months with nothing coming to us, and this was a problem. So what I could recommend in such a case, it's very important to be in touch with people who has to complete certification, because our knowledge is our knowledge we have right now. We have to look into the future. But according to the law, we have to use for certification, we have to use standards which are written down either with the rules or with the guidelines and so on. Bigger ships, bigger problems, of course, and the major problem could be lack of regulation. So in this case, we have to discuss the usage of similar way as with IMO 455, which allows you to to approve alternative design, providing the documentation, the information provided by the designers is able to assure you are dealing with equivalent safety level as with other classical rules. So, well, from us, it's not a problem to discuss any new issue, but the problem is that the discussion must be two-way. So we have something to get, we have to respond, we have to discuss the issues, how to mitigate potential problems. So, well, it's quite hard to give you exact date, but basically we are trying to be fast. However, we have to assure our assurance that our decisions are for safety, not for commercial success first, safety first.
Yep. Yes. Thank you for this answer. So as we heard from Anders and you, the safety is number one, and then all other other factors such as environment and everything else.
Yeah, well, as I could comment this, having full information about the operational area, we can decide that well, if for example the maneuverability or characteristic on waves is not allowing to operate the ship in all weather conditions in the area which is expected, yeah. So we can put some limitations, yeah. We can limit, for example, number of people on just to allow safe evacuation, yeah. So a holistic design, I think, is necessary. A holistic approach is necessary in this case as well.
Yeah. Thank you. Thank you. We will discuss more in the Q&A session. Now, please stop sharing your screen. And I invite Mr. Tomislav Uroda to share his screen and tell us more about his experience in Croatia with building and registering all-electric ship. Mr. Tomislav, the floor is yours.
Thank you very much. In last presentation, you have heard view of the alternative energy from the point of register shipping. And now I'm going to give you some overview from the point of design office and the shipyard. What we are doing, we are the shipyard for the electric vessels, focusing basically on the solar energy, if possible. But the newest project is not related to the solar cells, because we have designed the fast and full electric vessel, which the amount of energy you cannot get from the size of the roof where you can put the solar, so it will be recharging. In this presentation, I'm going to reflect to the boats we have built in last 5 years, and to give you some examples of applying new technology on such boats. What we are going to discuss is how to replace the diesel engine or diesel propulsion on the boats with alternative fuels, focusing on the electric propulsion. We have been designing the batteries as a storage of the energy. In our case, the lithium batteries, and some of you may know that there are different lithium technologies, and then you have to decide at the beginning where you would like to go. But anyhow, what you are doing is replacing some traditional equipment on board, which have been developed over the years, and those equipment, they are stable, they are functioning, everything works how it should be. And now you are coming with something completely new, where you are not completely sure what you should apply, and it's not just you, it's also the register of shipping. And just for the illustration, you will not have such standard engine panel like you can see it on the right upper corner, and that one you are going to replace with the panel PC, where you are collecting all the information about the propulsion system. In our case, we have contracted 4 vessels in 2016. 3 of them, they have been for the commercial customer, and 1 of them was from the EU project. And it took us some 4 years, 3 to 4 years, depending on the projects, to finish all of them and to deliver them. The magic was in between, and that was discussing how to apply new technologies, how to develop new technologies, and then how to regulate it, or how to get the class approvals. All the boats we have been building, they are seagoing commercial vessels, and as such, they are under the class approval by the Registry of Shipping. the first challenge, that was the lithium batteries. We have started dealing with lithium batteries even some years before we started the projects, and discussed that one with the register of shipping. For the Croatian register of shipping, the technology was completely new. They never faced application as such in Croatia, and from that point of view, they have to rely on some of the certification from the other registries, like the ABS, DNV, Lloyd, or similars. Our application of lithium batteries have started with communication to battery producers, suppliers of the batteries. At the end, we have chosen the one with whom we had the best communication. I would say that some of the battery suppliers, maybe they have bigger brand and more approachable technology, but we wanted to have somebody with whom we can discuss application, with whom we can put in communication channel with register shipping, and that was the decision for us, which at the end it came out it was the very good decision, because discussing with the register shipping how to apply lithium batteries, it's some kind of relations you develop, and it is not kind of process where you're just applying for the approval. It's much more communication, discussion, development on such a project. And then the second one, critical issue was flag rules. That means statutory approval, where in Croatia that was not present at the moment. If I start with the flag, then I can give you one challenge we had. On the picture, you can see 3 vessels which have been built for the commercial customer. And then there is one vessel which is within the EU projects. If you take a look on those vessels, they look the same, but the different navigation area, that means different rules to apply. And even though we got the positive letter from the register of shipping for first 3 vessels, for the 4th one, we got the rejection from the beginning, where they have been saying that by the national laws and maritime and general transport law, there are no regulation for the electric commercial vessels, and that the register of shipping is not ready to approve that one. And then it's that beauty I have mentioned before starts, and you have to start to discuss with them. And that was the EU project, so you have some obligations by the projects. And then you have to involve much more people in that communication. And at the end, we made it that register shipping accepted the approval process. That means approving documentation and following the new building of the boat. And once again, I'm saying the same shape, because this is the GRP boat, so we are using the same molds, but the different application. That means some different equipment on board, and complete different status from the register of shipping. Lithium batteries, this is just the illustration of one of the producers. It's not the one we are using. And then there have been a lot of fuss about the application of the lithium batteries. The register of shipping didn't have any rules about it. They have been relying on the sister register, I would say, or the ones from the same group. And there have been some of the rules, but not defined completely. I have to say that is 5 years ago. And then we have started discussion, what should we do to apply the lithium batteries? Then there was the document safety analysis for the lithium battery application, which we didn't know whom to ask, because there was not that much experience with the lithium batteries from the agencies who are doing that certification. Then you have to create kind of classification of space. The same issue and the same challenge. Who is going to do that one? And then at the end, we have some additional safety and other equipment asked by the register of shipping to be applied on the board. What I wanted to say here is it's not just I'm going to buy the lithium batteries and I'm going to apply it on the board. It's not that simple. It's much more complicated, and it's constant discussion and collaboration with the register of shipping. Some years ago, many of the lithium batteries suppliers, they have started to apply for the type approvals from the register of shipping, but they didn't get it at the beginning, and still those type approvals, they are kind of limited for the some applications. I told you that we have to start to develop something more from the point of the systems and the equipment to apply the lithiums on board. At one point, there was the guy from the Croatian Register of Shipping who was in charge, or mostly for the application of the lithium batteries, and he is basically electricians. These days we have kind of friends, and we talk to each other on a daily basis. We didn't know each other at that point, and we have been discussing all those applications on our first boats. And as one of my mentors used to say, the register of shipping is kind of Bureau of Statistics. So they are looking from the past experience, and what the experience brings to today, they are implementing in new rules. That was kind of collaboration with register of shipping for us. First, I will give you some examples of some issues which have been changed or decisions over the time. Having classification of space by the independent agency, they said, yes, if you put the lithium batteries in the compartment, it has to be ventilated all the time. We made some additional classification of space by the one Croatian automotive producer, which have stated completely opposite. They said the space where the lithium batteries are stored cannot be ventilated at all. It has to be sealed. So you have two complete different approaches and opinion about the applications of lithium batteries. At the beginning, on the first boats, we have the requirement that that battery compartment has to be ventilated all the time, where later on, we came out that it has to be closed in a case of fire. Very simple on the paper, very complicated later on to outfit the boat with some kind of closing vents and on the same application which is already developed. And then about firefighting or fire safety equipment. First, you have the fire pump station, which is quite a big one. Then we have the sprinkler station. Very strange if you think this is the place is full of electrical cabling. But the issue of sprinkler station is to cool the space. Then you have the hydrant. Then you have those automatic fire extinguishers like self-exploding ampoules. Then you have a set of fire extinguishers, different kind of, for this different application on the boat. And basically, there are several layers of safety on such a boat. And they all come on the top of the safety, which is integrated in the batteries, and that means the BMS, then the physical construction of the batteries, and then later the controlling unit for the whole batteries. Then we have came to the issue of monitoring system, and this is completely IT part, and it took us a lot of time. and a lot of money to develop such a software for the monitoring battery systems. Some of the first applications, they came from the road, because the batteries, lithium batteries, their applications at the beginning have been on the road. And then there is the huge difference between the road and the boats. The batteries we have applied, they have the alarm system within the battery, which is functioning on a way that if the voltage, temperature, or some errors appears on the batteries, they send you the message. For instance, the temperature is too high, we are shutting down the batteries. If you have the car, then this is okay, because you just push the brake and you just stop aside. On the boats, this is not functioning because there are no brakes on the boats. You are braking with the engines. So the alarm system on the batteries have to be redesigned. And that was something we have been doing together with the battery producers. Basically, they have been redesigning the alarm systems. We came out with something which we have called the pre-alarms. And then the functioning of those pre-alarm is like the temperature is rising and the batteries could shut down in a few minutes or soon. That means that you should decrease the power, or you should stop aside by the engines and to check what is with the batteries. Then discussion with the register shipping was what kind of information should we have from the batteries? What is the data we should need to have on navigation bridge? Is it the voltage, temperature, current, state of charge, etc.? So that was the development, negotiating with register shipping and battery producers what we can get from the batteries and what we can create in information system on board. Then we have the issue about the sample time. That means how fast do you need those informations? Are you collecting on each second the information about the voltage and temperature? Or this is the on each minute, or it should be even less frequent. We started with 1 second and we create complete mess, because you have the battery system of, I don't know, 50 batteries. Each battery have several cells, and then you're collecting so many information on the level on a second that you are killing communication between the batteries. And at one point, they don't manage to work and communicate in between. And then the discussion was what kind of information system do we have to have it, or what kind of system we need to have it. It has to be hard wiring system. So all these wireless features, you can find it and they are convenient to apply from the different IT companies. They are not working on the boats, because you have to have hardwired communication and there is lots of wiring on boat. Sea trial on the first vessel, that was with the customer and with the register of shipping. And we have been sailing. And by the way, the boats, they are fully solar and they have the daily autonomy of 100 nautical miles. So we don't have to recharge. We don't have that issue with the boat. But on the sea trial, on the monitoring system we had, there was some mess in communication, meaning that from time to time we have the pop-up of the high voltage. And the high voltage, if you go from the 50 volt to 1000 volts. And for sure there was something not functioning how it should be, but we didn't know what it is. And then the register of shipping is just rejecting the sea trial. It goes home and you have, I don't know, 2 months to improve the mistake. We were discussing with the battery producer, engine producer, producer, what kind of EMC noise is on the network, because the electric engines, they also have the issues with high frequency controllers with us, which are sending a lot of noise on the system. At the end, we found it out that one of the connectors on one of the battery was loose, and that was the cause of those false information, so false data. This is the experience, I would say. If you would have 20 years of experience in application of such batteries, then the guy from the Registry of Shipping would tell you that this is something mechanical. It's not the IT mistake, and you will get it passed through very fast because you will know where to look for it. But with new technologies, it's always the new development. The monitoring system, we have it on board, but we have it also online. So all the time, the owner of the boat can control where the boat is going, what is the state of the batteries, the current voltage, state of charge, and the upper right side of the picture, it's one of it's preview from the online monitoring for one of the boats, where you can see for each battery set what is the state of charge, and you can go deeper inside of that one, and you can get information on the battery level. And then one huge challenge in the new technologies is crew and service. For the delivery of those electric vessels, we have the distance of 75 nautical miles from the shore to the final destination. And then I came to the harbor master office and discussed with them how they are going to give us permission to sail there, because this is kind of temporary permission for the one voyage. And I know the guy there told me, yeah, it's okay. I know that I have to put the captain on board, but I don't know whom I'm going to put in the engine room. Is that going to be mechanic or the IT guy? And then you are coming to those regulations which are not regulated yet or not developed. So it's not defined who is the crew on the board or what kind of qualification they should have. And related to the same, crew is not maybe always ready for new technology, because they are familiar with the diesel engines and they are familiar how the diesel engines works, but they are not familiar with the new technologies like the electric engines. And I know that one of the captains on the first boats, he told me that he is very convenient with the diesel engines because he can hear the engine, but here he cannot hear any sound, and this is not nice for him. But I told him, if there is such a silence here, then you will hear if something wrong is happening in the engine, that's for sure. But later on, you are coming to the service of the boats, and you are replacing those mechanics which are coming with the oil can and replacing the oil, and with dirty hands, you are replacing them with the IT guy. One of the latest visit to the boats was the service on the engines, and then we came together with the engine company, and I was thinking about it. It's completely different set of qualification you would need to service such an engine, because you are programming the chargers, you are programming the batteries, you are programming the monitoring system, and you are programming the engines. And all those components, they have new firmware, new softwares, and sometimes something can malfunction. It's just like on PC, you have it. Sometimes something happens, and maybe some application would not work correctly. And to solve that issue, you need to have somebody who is familiar with the IT and programming, and that is the challenge for the owners of the new vessels which are now electric and full of IT. And this is where I'm going to stop today with this short overview of application and new technology from the point of design office and the shipyard.
Thank you, Mr. Uroda. You can now stop sharing your screen, and I invite other panelists to join with their video to start a Q&A session. And I would like to start with Mr. Uroda. I remember one sentence from your presentation: administration is not prepared for the all-electric vessels. That was the situation, I think, 5 years ago when you started the project. Is it now a different situation? Is it now is something changed, or is it is lithium-ion batteries in shipping in Croatia still a new technology?
Yeah, of course, it's still new and it's going to stay new for some time. If you ask the register shipping, you will get the better explanation of that one. But first, they have to collect some experience. They need some elaboration of the application, and then somebody has to rewrite the rules. And what we have missing in Croatia, it's the flag rules, where it's not predicted to the electric vessels to be operated at all. So for some time, it will be case by case approval, I would say.
Mm-hmm. Also, I have additional question. You said when the batteries are not functioning as they should be, you receive some kind of errors and the battery is switched off. Is there some kind of an additional battery to start a vessel to go on, or the vessel is just out of function?
This is the issue of the design. We have the high redundancy on the boats. That means redundancy on the boat can be on the level of the string and then on the battery banks. And we have created redundancy that even though if one battery pack is not working, you can operate complete vessel from the another battery pack. And then the redundancy level we can increase on the level of string. That means if one battery from the one string of the one battery pack is not working, you can use the pack using the other strings of that one. And then this is the issue of customer. They have to decide if they would like to have it or not, because they have to pay for it. So whatever kind of equipment you're adding, somebody have to pay for it. And the challenge with the register of shipping, I would say the design office would always like to follow the register of shipping, but at the end, the customer is the one who have to pay for that one. We would all like to design as much as equipment on boat and the space vessels, but there is price for that one.
Yeah. I would like to ask Mr. Walland something about tank to wake and well to wake. When we consider these two terms, which technology comes to your mind as technology that is right for shipping? Is it batteries or hydrogen? Or I'm talking about green hydrogen, of course. Please unmute. Wait, I will send you. Yeah.
I don't think there's any clear answer to your question. I think that it's what will be the best is still a matter of the application. So it's because there are so many other aspects to it as well. But the reason we bring the well to wake versus the tank to wake perspective into it is as long as you're looking at global emissions, and greenhouse gas emissions are global. It doesn't matter if you look at if you want to reduce greenhouse gas emissions within one country. if you're using a fuel that makes emissions go up in another country. That's why we want to have this total well-to-wake perspective, because we need a transparent way and a consistent way of comparing the different fuels. So at the end of the day, if batteries are better than hydrogen, or hydrogen is better than batteries, I don't think there's a clear-cut answer to that. And today, there's still a lot of work to be done to make these production figures come out and be transparent. So it's really hard work to get all of these production figures. Everybody wants to frame their production in the best way possible, and really digging into it and figuring out what the real numbers are is difficult to find.
Additional questions from your point of view. What is the situation with administration in Norway? Is the lithium-ion technology or hydrogen new, or do you consider that as a technology for use today, or is it for the future?
Well, if you look at Norway, we have a lot of projects going on and a lot of vessels being built, but most of these vessels that are, for the most part, it's battery electric vessels or hybrid vessels where you have a diesel engine and a battery pack. For the most part on pure battery electric vessels, these are publicly operated vessels. So it's the government is actually buying the service. So if you look at ferries, for instance, the government is the one who is buying the service, which means the government has the power to spend as much money as they would like, which is also necessary because you're introducing a new technology that comes in at a higher cost level than the competing technology that has been in place for 100 years. If you look at hydrogen, we don't have any operating hydrogen vessels as of yet, but they're coming. That's also a ferry, the first one. But these are only at the demonstration and piloting stage as of yet. So, but the emphasis right now is to try and utilize batteries as much as possible. So I can give you an example. When I started looking into this back in 2014-15, I think that the basic idea on battery electric vessels was small vessels going slow on short distances. Those three. Today, I think that going slow is not necessarily a point. You can go fast, but I think also going fast limits a bit on your range. But I think everybody is agreeing now that the range can be quite large. You can go quite large distances. And the interesting part is when you start playing with everything. If you say that, for instance, one of the builders of high-speed light craft in Norway said that, okay, if I take an existing design, the one that uses diesel engines today, and I try to fit batteries into it, well, I can either go fast or I can go far, but I can't do both at the same time. But then they said, however, if I'm allowed to design the boat to use batteries, I can go both fast and far. So suddenly you get suggestions on vessels going 30 to 32 knots with an operating range of 3 hours, maybe 4 hours on batteries. Then it starts getting interesting. If you look at the high-speed light craft routes in Norway, suddenly you're covering a large proportion of routes. And also, this has then spurred the discussion on, okay, so should you have batteries on board and charge from shore? That takes time, of course, and you need to change schedules on vessels and so on. Or should you have a kind of a plug and play capability? And how can you do that? Do you need to plug and play the entire battery every time? Or could you do as Tomislav was talking about? So maybe you can play with sections of the battery. So you have sections of the battery fully charged at any time, and you can change this part of it. Because of course, changing a 40-ton battery in 10 minutes, that's a bit of a challenge. But if you could change smaller parts of the battery, maybe it's possible. So there's a lot of, I think that it has just opened up a lot of ideas on how to solve this. And then, of course, you bring foils into the question. So instead of having a catamaran, traditional catamaran, suddenly you have a foil lifting the entire vessel out of the sea and being able to operate at very low resistance values. So there's just a lot of new ideas, and I think that from my perspective, I'm a researcher, so I love these new ideas and the ability to test everything. And I think that the Norwegian government and Norwegian Maritime Authority are opening up for the idea that we could test a lot of different technologies without necessarily thinking that this will be the end solution. So we need to know more, and knowing more opens up more doors to new solutions.
Yeah, thank you, Mr. Walland. Mr. Narevsky, when you heard the experience from Tomislav Uroda from Croatia, what are your thoughts? What is the situation with when you consider Poland and Croatia about registering all electric ships? I unmute, please. I sent you a. Mr. Narevsky, please just unmute. Yeah, okay.
Yeah, right now, I'm quite happy to hear about the projects which are in some way very similar to something we did. Our task was a little bit easier because the application was for inland waterways. However, it was done 10 years ago. So especially in this project. Right now we have in Poland, I think 3 or 4 projects undergoing with electrical boats. I think this boat with the twin hull is to be with the register. The other are managed by administration, and I must say that I'm a little bit afraid of some braveness of people who are trying to construct, to design, construct, and build a craft which are not fully evaluated with safety in mind. So a lot of components are available on in the market. Yeah, it's a lot of automotive equipment. Maybe not all type of this equipment is suitable to be used in waterborne application because, for example, of materials and lack of knowledge how it will be operating, what it will be behavior in a longer time. Well, it's I think very important is ability to share a knowledge. This is something which is very important right now when we have new technologies, maybe not so well supported with funding as technologies which are implemented in automotive industry. But I think ability to have forum for exchange of data is very important. It's very important to provide a kind of backup information exchange, even if there is no commercial relation. Of course, commercial relations are helping. Sharing knowledge is quite typical, and cooperation within classification societies is possible as well. We have arrangements with other class societies. Such arrangements, up to my information, is also with Croatian register. So we are able to cooperate. We are working on a similar issues, and I remember in the past we were a member so-called Inland Waterway Ajax. Well, Ajax is not right word right now, but there is still an organization which is managed by Russia, a kind of association of classification societies dealing with inland waterway shipping. And it was quite interesting example of cooperation which succeeded with the development of rules for ships operating in rivers and shore shipping, because the requirements of Russia, for example, for ships able to sail in inland waterways are quite unique. So we are still able to benefit from such rules. Mainly they are dealing with construction of the hull, but progress with electrical IT and battery technology is so fast that really the forum to exchange information is very, very important. I know that DNV, for example, arranged some time ago kind of association, a battery forum, which is, I mean, a good example of ability to get some information. Of course, it's I know some people which manage to do that, and I think it's a very good idea. But of course, there are some rules of association, and so one is interested, the other not. But safety is very same for all countries. Yeah, we have people. We have to provide a safe way of evacuation, and this is managed by Marine Equipment Directive in European Union. Regarding inland waterway shipping, there will be this ESTRIN regulations. So, of course, this is something very common. However, approach of people from inland waterway shipping is quite different than the experience and approach people which are dealing with bigger ships. So, sea applications, when we have open water or blue water, are much more demanding than inland waterway shipping. However, disasters on the inland waterways are going to very painful as well. You probably remember 2 or 3 years ago the accident with passenger boat in the Duna Bay in Budapest. Yeah, the collision with cruise vessel, and the boat sank within a minute. So this is a problem I touched with in my presentation. Yes, small boat demands sometimes more stricter requirements to be complied with, especially reserve buoyancy. Yeah, so in a small craft, maybe there's a limit for people. Well, it's a just idea. Yeah, percentage of buoyancy which is able to secure ship systems, a percentage of buoyancy which is able to secure survivability of people. Yeah, the possibilities are quite different, but well, there are physical limitations. Yeah, we can have 12 people on board for pleasure crafts, but in case we are dealing with passenger ship or cruise ship, small one for shore, close to shore operations, we have to deal with different conditions that in inland waterways. So I'm quite positive to look on the smaller ships. We can benefit from the knowledge which is just being evaluated, not always shared by the bigger companies, but there are some new opportunities with funding, which is being just now released by European Union according to Green Deal, and there's a lot of money for well, lot. Demands are probably not much bigger than the number of people, number of companies, but with some projects, why not? We can develop quite good solutions for the future. And especially, I think the knowledge is being gathered right now. And as I heard discussion about this fire problems, I know the project which was done by producer of buses. They managed controlled fire on a bus, just to get full picture what's going when the bus is in fire, yeah, when the bus is in flame, and they got results which presented that in a couple of minutes the temperature is over 1000 degrees. Yeah, the total fire lasted few hours. So very important for ship is to be able first to evacuate the people. The second, depending on the type of fire, you have to select to do something or not to do. First of all, you have to secure safety. If the fire is within the harbor, well, what to do, because nearby maybe boats, maybe situations, and situations requiring removal of some boats or protect harbor infrastructure. But well, it's a problem to seal battery, or what to do with battery. Yeah? Big batteries, big power. Yeah, so removal of battery is not possible. But according to recent developments, the approach for batteries to be used on board is to provide modules which are secure itself. So stack of batteries, or the complete batteries, consist of several modules, and the approach is that fire within one module will not result in spreading fire on the neighboring modules. So of course the other issue is to provide cooling, detection of increase of temperature. I think it's a nice subject to be researched as well. Well, why
Yeah.
not together?
Thank you, thank you. We have additional questions. Question from our participant to Mr. Uroda and Anders. You could also jump in. How is with the registration and education for the crew for the electric ships? Is there a connection, or is it such a new technology that is not yet implemented? I remember that on the last plenary sessions the week before, we talked about safety. We can just maybe cover this topic and connect it to the topic a week before. Mr. Uroda, you could start.
Yeah, there are no education programs for the electric vessels. At least I don't know for them. So the education is mostly related to the shipbuilder, just to educate the crew and the people who are going to operate the boat how to deal with the equipment. Probably this is going to be one of the new programs on the faculties, like maritime studies, but so far there are not official education procedures. And I didn't understand completely how is that connected, registration with education. Well, the register of shipping, it's not asking for that kind of education, because there are no education on that level. And the only issue is defining who would be the crew on the boat for the such vessel. So we have been dealing with the small vessels that's 54 passengers, and we didn't have some special requirements.
Mr. Anders, what is experience from Norway? Is there some kind of rule to have this crew, IT guy, electronic mechanic?
As far as I know, but I must say I'm not an expert in all the rules. But as far as I know, it's the same here as Tomislav was saying. There are no specific crew training requirements, but of course they would need to familiarize themselves with the system, as you would with any machinery or propulsion system. But there is no specific requirements as such. I think that with the recent experiences we've had with some incidents of fires and other incidents with battery electric systems, there will probably be some kind of, at least when it comes to the firefighting procedures and so on, they will probably be updated, and we need some new competence in that area. But beyond that, I don't think there is.
So basically, all the crew which is working currently on a diesel ship, they are safe with their job. They will go on additional educations and they can stay.
Yeah, I think so. For a battery electric, at least, I think so.
Okay. I now invite each lecturer and panelist to say a few words for closing this plenary session. Mr. Walland, you can start, and then I invite Mr. Uroda, Mr. Nerevsky, and then Mr. Uroda, and please say a few sentences.
Yes, thank you. I think it's been a very interesting webinar. I think you got this covered from several different points of view. You got the classification side, and you got the an authority, and you got the ship owner, and you got me as a research perspective. So I think it's quite interesting, and all of these presentations show that we are in new waters and we're early in the game. So it's a lot of things that we need to learn yet, and we need to be aware of the risks and the potential yeah, the potential ways of going wrong. So we need to be aware as we're moving forward, and try and keep a decent pace in making new solutions, and not just plunging ahead into new solutions. So yeah.
Thank you. Mr. Norevsky.
I'm quite happy to have a chance to discuss the issues we are dealing with partners from Croatia, from Norway. I think education is something which is to have place rather on the universities, or maybe on commercial companies doing training for some people. But classification society basically limits our activities to safety. So all operational issues which are not over control of the classification are, well, not prime interest of ours. Of course, we have to we have obligations from the flag states, yeah, and the flag states requirements, competences of crew, competences of people are something we also are looking at, but this is another type of surveys. I think that quite important is to be able to collect this knowledge as well. One way is to take part in the projects. The other is maybe by continuation of such information exchange or contact exchange, because I see that we are dealing with very similar projects. Maybe our interest will go to the bigger boats, but the number of smaller applications, smaller investment of boats, I think it's quite substantial. And even if in Europe there are problems with contracts for big shipyards, production of leisure craft, smaller craft, and so on is quite substantial. So providing safety for this type of applications is, I think, in the interest of all stakeholders involved in this. So once again, I would like to thank you for ability to contact you, even in a remote digital way. But well, I think maybe it's not the last meeting. I would like to recall a kind of training or kind of meeting we did, I think 2 years ago. It was totally devoted to a problem of fires on board. Maybe this is a subject we can discuss, because fires and fire protection is something which is quite often neglected by, as I said, the EMSA statistics says over 30% of events we have on board are fires. In case of naval ships, there is some statistics on this. Over 30% accidents were fires, some of them very, very disastrous. So it's a problem with new materials, new technologies, and especially something which is not very well. I mean, we do not have knowledge. Yeah, with diesel, we have over 100 years of experience. Hydrogen is known a long time ago, but knowledge about the usage of hydrogen energy is just being created. So let's learn together. Thank you.
Thank you, Mr. Uroda.
I would say that the electric vessels, they are the future, and like I usually say, what is happening on the road today, it will happen in 10 years on the sea or in the inland navigation. All national waters, inland navigation could be covered by the electric vessels, and I'm saying that also for Croatia. Complete traffic between the islands could be electric. Norway is a great case, or the showcase how the government should support that one, and I hope that Croatian government will follow some of the principles and rules like Norway is doing, and that means supporting electric propulsion. In near future, short routes, they are going to be covered with the batteries, and then for the longer routes there will be some kind of combination of the batteries, hydrogen or just hydrogen. But also it's my believing and thinking, I would say that the battery technology is developing, and is developing fast, and it's not something which are the shipyards or designers are working on, but the guys who are working on the batteries, I believe they will come with something, with some technology on the batteries, which will be more safe and with more energy density. And in such a case, then we have the solution, and we have solved all these issues with the safety and with the range of the shipping for the electric vessels.
Thank you. Yes, we came to the end of our webinar, to the end of our plenary sessions. This was the final one. I hope that in the future, the ZEVinnovation will and must organize more of these webinars, because as we saw, we really share a knowledge and experience from other countries and compare it to our. We find what are the obstacles, what are the opportunities, and we also find new solutions. I would like to honestly thank to all panelists and lecturers who joined us and wanted to share their experience and knowledge. This means a lot, not only for our project, but for our countries. And please, we will, to our participants, thank you for joining us. You will have this webinar, as all other webinars, on our YouTube channel, on our Facebook page or LinkedIn. So you can see and watch again if you want. Thank you all. That's it for today. Thank you.
Thank you. Goodbye.
Bye-bye.
Thank you.
Bye-bye.